Hello everyone, my name is Oscar Rondon and I'm going to present you the poster entitled Chitosan Films, Tailoring Properties for Sustainable Application through Casting and Electrospinning. In the last decade, biomaterials of natural origin have gained prominence in various fields due to their outstanding advantages such as biocompatibility, biodegradability, and non-toxicity. Among these biomaterials, chitosan stands out as one of the most abundant and promising biopolymers. Chitosan is a highly versatile material with potential application in various fields due to its amine and hydroxyl functional groups, which promote absorption and condition. However, the interaction of chitosan with acid solvents can modify its properties and structure, affecting the crystallinity and porosity of its derivatives, such as chitosan films. This study compares to the physicochemical and thermal properties of chitosan films obtained by two methods, electrospinning and casting. Characterization techniques such as FTIR, TGA, DTG, and physicochemical properties analysis were used to evaluate the differences between the films produced by both methods. The methods used were casting and electrospinning. For the former, chitosan was dissolved in 1% acetic acid, and the solution was poured into petri dishes and left to stand at room temperature for 48 hours. For the second method, chitosan was hydrolyzed and dissolved in a concentrated acetic acid solution. The solution was loaded into a syringe and electrospun at 25 kilovolts. The results obtained by ATR FTIR for chitosan shows absorption bands for the hydroxyl and amino groups in the range of 3,500 to 3,250, as well as band at 1737 and 1593 wave number, indicating the presence of carbonyl and amine groups, respectively. For chitosan treated with acetic acid, it shows a characteristic vibration of the methyl group at 280,082 wave number and bands at 1545 to 1637 wave number, suggesting protonation of the amino group. And for electrospun chitosan, the spectrum shows slight changes in the bands, such as reduction to 3355 wave number, indicating a lower number of intermolecular hydrogen bonds, and an increase to 1709 wave number, indicating a higher degree of the acetylation. The bands in the range of 1120 and 1151 wave number confirm the preservation of the basic structure of chitosan. However, the results of the physicochemical properties show that the cast films have a porosity of 16.5%, while the electrospin films have a porosity of 21.5%. The higher porosity of the electrospin films is due to their fibrous structure, which creates a network of interconnected pores. On the other hand, cast films have a moisture content of 15.7% compared to 18.2% for electrospun films. The difference is not significant, possibly due to the structural reorganization during the dissolution process. Now, talking about swelling power, cast films show a swelling of 83.59%, while electrospun films have a swelling of 93.63%, suggesting a higher absorption capacity in electrospun films. The variation depends on the concentration of the acid used, and finally, the solubility of the electrospun films show higher levels of solubility due to the higher porosity and the inclusion of more water molecules. The TGA-DTG results for chitosan shows two stages of weight loss. The first between 47 to 100 degrees centigrade due to the water loss, 9.07%, and the second between 247 to 450 degrees centigrade related to the composition of acetyl on amino groups. 53.88% loss and 30.915% residual ash. The decomposition temperature is 290 degrees centigrade, indicating a high degree of the acetylation for chitosan with acetic acid. It shows an initial weight loss of 11.87% at 120 degrees centigrade, attributed to moisture, and 52.59% loss between 190 degrees centigrade and 200 degrees centigrade due to the decomposition and evaporation of residual acetic acid. The DTJ curve shows peaks around 82.6 degrees centigrade water evaporation and between 217 to 290 degrees centigrade decomposition of chitosan and derivatives. And for electrospun chitosan, it exhibits 2 steps mass loss to 27.07% due to the water evaporation and 41.45% due to the composition. The DTJ curve shows 3 peaks to between 45 to 115 degrees centigrade and one between 250 to 260 degrees centigrade related to water evaporation and chitosan decomposition. The peak between 280 to 300 degrees centigrade suggests that the thermal stability is influenced by the acid-base treatment and the electrospinning process. In conclusion, films obtained by electrospinning have a higher porosity and water absorption capacity due to their fibrous structure compared to cast films. Despite the differences in porosity and solubility, the manufacturing methods do not significantly affect the moisture content of the films. Finally, the thermal stability follows the order chitosan, acetic acid chitosan, and electrospinning chitosan, indicating that the electrospinning process and the acid-base treatment negatively affect the thermal stability of chitosan.